Assalamualaikum and hi everyone. So today we are going to continue with topic 5 on exception handling. So the objectives of this topic is it should improve your reliability of code by incorporating exception handling. You should be able to implement the try-catch blocks for catching and handling exceptions. You should be able to write methods that propagate exceptions, and you should be able to distinguish the checked and unchecked exceptions. So an exception represents an error condition that can occur during the normal course of program execution. For example, if you try to divide by 0, you will get arithmetic exception. So if you try to open an input file that does not exist, then you will get an exception. So we have seen that if we try to read an array index that goes out of bound, we get the index out of bound exception. For example, so I have put this code on your online learning as well, so you can try and run it. So say that we have system.out.println 5 divide by 0. Because we are dividing by 0, it will give us arithmetic exception. So for the array part, say that we have int a equal to new int 2. So we know that when we say the length is 2, we can only have the index of 0 and also 1. So if we try to do system.out.println a2, we will get array index out of bound exception. A Java exception is an object that describes an exception or an error condition that has occurred in a piece of code. When an exception condition occurs, an object representing that exception is created and thrown in the method that caused the error. So it tells what the error is in your code. The exception handling codes can then be executed to catch and handle the exception object. We say the thrown exception object is caught. The normal sequence of flow is terminated if the exception object is thrown and not caught. For example, say that in our code we have system.out.println 5 divide by 0. So when it gets to that part, it will throw the exception and terminates your program. Say that if we have system.out.println 5 divide by 0, and then the next line we have system.out.println print something. Because it gets the exception 5 divided by 0, then the next line will never be run. But if we have the catch, then when it catch the error, the next code can still be run. Consider this example. Assume that the code can compile just fine. So in here we have our scanner. So we have scanner scan equal to new scanner system.in, and then it asks the user to enter an integer. It takes in the input, and then it will print out the number you entered is whatever number that you have entered. So over here, it shows an error message for invalid input. Say that the user entered 3 in word rather than 3 in number. So it will give out an exception called input mismatch exception because it expects the user to enter a number, but instead the user enter a word. So that terminates the program, and it will never run the last line, which is the number you entered is. But if we have the catch, then we can still have the last line, which is the number you entered is. We will look into how to catch it in the next few slides. From the example, the execution of main stops because once an exception has been thrown, it must be caught by an exception handler and dealt with immediately. If we have no exception handlers of our own, the exception is caught by the Java runtime system. The default handler displays a string describing the exception, prints a stack trace from the point at which the exception occurred, and terminates the program. Java provides a number of exception classes to effectively represent certain common exceptions, such as division by zero, invalid input, and file not found. For example, when a scanner object is used to input data into a program, any invalid input errors are handled using the class input mismatch exception. When a division by zero exception occurs, the program creates an object of the class arithmetic exception. All types of thrown exception objects are instances of the throwable class or its subclasses. Throwable is at the top of the exception class hierarchy. Immediately below throwable are two subclasses, error and exception, that partition exceptions into two distinct branches. Serious errors are represented by instances of the error class or its subclasses. We don't deal with error type because these are typically created in response to catastrophic failures that cannot usually be handled by your program. So, error indicates serious problems that a reasonable application should not try to catch. It is an abnormal condition that should not occur. Exception cases that common applications should handle are represented by instances of the exception class or its subclasses. Throwable hierarchy. There are over 60 classes in the hierarchy. You can refer to the Java API Throwable to show the whole list of the hierarchy. Over here, under Throwable, we have error and also exception. Example of classes under error would be out-of-memory error and also stack overflow error. While in exception, we have I/O exception, which is input-output exception, runtime exception, and we have seen arithmetic exception, array index out-of-bounds exception, and also input mismatch exception. Java exception handling is managed via 5 keywords: try, catch, throw, throws, and also finally. We will look into all of this in the next slides. Catching an exception using try and catch block. To catch an exception, put code that might throw an exception inside a try block, and then put code that handles the exception inside a catch block. The way to write it is you would write try, curly bracket, and then all the statements, some of which might throw an exception, and then you would write catch, some exception type, and then the statements to handle this type of exception. Catching an exception. Let's look at this example. So we have scanner scan equal to new scanner system.in, and then we have our try and catch block. Inside our try, we have system.out.print enter an integer. We would expect the user to enter a number. But if the user enter a string, then it will be catch inside our catch block, where we have our catch, and then the type of exception that we expect, it would be input mismatch exception, and then we have a variable called e. So you can call it anything that you want. And then inside the catch block, if the user enter other than an integer, we will print out invalid input. Please enter digits only. After the catch block, it will print out the last line, which is the number you entered is, and then some number. If you try and run the code from the previous slide, say that you enter a string 3, then it will go to the catch block and print out invalid input, please enter digits only, and then it will execute the last code which is outside of your try and catch block, which is the number you entered is 0. But if the user enter the correct input, then it will not go through your catch block. In our example before, in our catch block, we are using input mismatch exception. So we are being specific on what kind of exception that we will catch. But if you are not sure what kind of exception, you can always use exception, which will catch all exception, but we do not know which exception we are referring to. Try catch control flow. Assume that the statement throws an exception. So when it finds the exception, then the rest of the part inside the try will be skipped and it will go straight away to the catch. But if there is no exception, it will go through all the codes that we have inside our try and it will skip our catch block. There are two methods we can call to get information about the thrown exception. So we have getMessage and also printStackTrace. So we will write this inside our catch block. For example, inside our catch, we are catching the number format exception. So it can be any other type of exception as well. And if we want to use getMessage, we have to use system.out.println e.getMessage, where e refers to the variable that we have defined earlier. Or if we want to get the name of the exception, then we can use printStackTrace by writing e.printStackTrace, and it will print out the name of your exception and where it occurs. For example, referring back to the code that we have seen previously, so I have added inside the catch e.printStackTrace. So I use e because in my input mismatch exception, I have the variable e. If I call it something else, say that if I call it exp, then inside my catch I would use exp.printStackTrace. So when I run this code, it asks enter an integer, so I enter a string. It prints out invalid input, please enter digits only. And then the next line, it should print the stack trace, which is the name of the exception. So it says over here, java.util.input mismatch exception. And then it lists out where it happens, which is at try_catch1.java line 17. And then the program ends. So you can see that the program does not terminate halfway. So it runs everything until the end. A single try-catch statement can include multiple catch blocks, one for each type of exception. For example, over here we have our try, and then we have our catch block. For the first one, it will catch for number format exception. The second catch block, it catch for array index out of bounds exception. So we can have as many catch as we want because it will deal with different types of exception. Multiple catch control flow. Assume statement 3 throws an exception and catch block 3 is the matching catch block. So we have our try, it finds the error, so it throws the exception, and then it checks which catch block can deal with that exception, and then it will execute whatever inside that catch block. If there is no exception, similar as before, it will run through all the code inside the try, and then it will just skip the catch block. Only one catch block gets control, which is the first block that matches the type of the exception. If no catch block matches the exception, none is being picked. So that is just the same as if there were no try block. When we have multiple catch control flow, the most specific exception types should appear first in the structure, followed by the more general exception types. a child class should appear before any of its ancestors. If class A is not an ancestor or descendant of class B, then it doesn't matter which appears first. For example, the following is wrong because we have the exception comes first before the arithmetic exception, because exception covers all types of exception. But if we write it the other way around, meaning that the first catch block is arithmetic exception and then the second catch block is exception, then it should work just fine, because inside the try, say that we have arithmetic exception, then it will go to the arithmetic exception catch block. If there is other type of exception that happens, then it will go to the general type, which is just the exception. So question, is this okay? So we have our first catch block, number format exception, and then our second catch block, arithmetic exception. So this works just fine, because if you check in the hierarchy, it doesn't really matter. You can try and change the positioning of it. Try and write if you have your arithmetic exception first, and then your second catch block is your number format exception. It should work just the same. Now we are going to look at the finally block. There are situations where we need to take certain actions regardless of whether an exception is thrown or not. We place statements that must be executed regardless of exceptions in the finally block. So we have over here, we have our try, and then we have our statements, some of which might throw an exception, and then we have our catch block, some exception type, and then we have another catch block, another exception type, and then we would have our finally block, where it says over here, it would be the statements that will execute no matter how the try block was exited. Try, catch, finally, control flow. Assume that statement I throws an exception and catch block I is the matching catch block. So it goes through the try, find the exception, and then catch it inside the catch block, and then it will go to the finally block and then ends it. If there is no exception, it will go through all the codes inside the try, and then it will skip the catch blocks and it will go straight to the finally block. Propagating exceptions. Instead of catching a thrown exception by using the try-catch statement, we can propagate the thrown exception back to the caller of our method. The method header includes the reserved word throws. For example, here we have public int getAge throws number format exception. That means that whoever that called that method, they should deal with any of the exception that might happen. Let's look at this example on propagating exception. So this code is on your online learning. I have uploaded it. You can try and run the code and see what is the output of it. So over here we have public int getAge throws input mismatch exception. So whoever that calls getAge method should deal with the exception. GetAge only stated that input mismatch exception could happen. It is an unchecked exception, which is caused by defects in the code. So the user can choose not to handle the exception if it happens. So inside our main method, we call our getAge method. So inside our main, we can write our try and catch, because inside getAge method, it does not deal with any exception. So the try catch in the main method, it is not compulsory. The program can still run without the try catch. But if we have our try and catch, then we can write try, we call the method getAge, and then we can catch input mismatch exception and display any message when input mismatch exception happens. Throwing exceptions. We can write a method that throws an exception directly. This method is the origin of the exception. Use the throw reserved to create a new instance of the exception or its subclasses. The method header includes the reserved word throws. So you can look at the code over here. We have public void do work int num throws exception. And then we want to throw an exception directly. So we can have if num not equal to value, throw new exception. And then the message that should appear is invalid value. Let's look at this example. So this code is also on your online learning, so you can try and run it. So what happens over here? We have the method header that has the reserved word throws. And then we have our method. So we have public static void main throws exception. And then we have our scanner. And then we ask the user to enter a number from 0 to 10. And then we want to use throw so that it will throw an exception directly. So we have if number is larger than 10 or number is less than 0, it will throw new exception and the message that should appear is invalid number. So if I run this one and I enter 100, so it gives me the error exception in thread mean java.lang.exception invalid number, because that is the message that I want it to be displayed, which is invalid number. Exception thrower. When a method may throw an exception either directly or indirectly, we call the method an exception thrower. Every exception thrower must be one of the two types, so it can be a catcher or propagator. Using the try-catch statement is the first way to handle the exceptions. The second way is to propagate the thrown exception back to the caller of the method. The method that includes the statement that calls our method must either catch it or propagate it back to the caller. Types of exception throwers. An exception catcher is an exception thrower that includes a matching catch block for the thrown exception. An exception propagator does not contain a matching catch block. A method may be a catcher of one exception and a propagator of another. It is possible to throw an exception from our own method. Sample call sequence. We say a method throws an exception directly when the method includes the throw statement. Otherwise, a method is throwing an exception indirectly. So method A and B are throwing the exception indirectly, while method D is throwing the exception directly. Okay, so what happens over here? We have method A. In the try block, it calls method B. So we go to method B, and then inside the try block, it calls method C. So method C, it calls method D, and method D, it throws a new exception. So it propagates the exception back to whoever that calls it, which is method C. Because method C does not deal with the exception, it propagates it back to the calling method, which is method B. And then in method B, we have the catch block. So it will catch the exception and print out the letter B, because method B is now the catcher. See that if method B does not have the catch block, if it does not have the catch block, method B will also be a propagator and pass it back to method A that calls method B. So if that happens, then method A will catch the exception and print out A. The codes for method A, method B, method C, and method D are available on your online learning. So you can try and run those and see what would be the output of it. In method B, I have written two methods where you can try and comment the first one and uncomment the second one to have your method B act as a propagator and your method A act as a catcher. To summarize this sample call sequence, method D throws an instance of exception. The green arrows indicate the direction of calls. The red arrows show the reversing of call sequence looking for a matching catcher. Method B is the catcher. The call sequence is traced by using a stack. Checked and unchecked exception. There are two types of exceptions. So we have checked and also unchecked. A checked exception is an exception that is checked at compile time, so it must be handled. An unchecked exception is not checked at compile time, so no need to handle. So it is optional if you want to handle those kind of exception. Unchecked exception include error and runtime exception and their subclasses. Checked exception includes exception and its subclasses. For example, checked exception, it can be a file because when a program cannot open a file if it does not exist, so it needs to have an exception to make sure that the file exists. Unchecked exception, it is caused by defects in your code. For example, array index out of bounds exception. So this can be avoided by checking your code. Here is showing the unchecked exception. So we have arithmetic exception and also array index out of bound exception. So these unchecked exceptions, they are optional to be checked. That's why in the code that we have written before, which is before we learn about exception, we did not catch whatever happens in the arithmetic and also in the array index out of bound. Different handling rules. When calling a method that can throw checked exceptions, use the try-catch statement and place the call in the try block or handle the exception. Or you can modify the method header to include the appropriate throws clause to declare the exception. When calling a method that can throw unchecked exceptions, it is optional to use the try-catch statement or modify the method header to include a throws clause. In handling checked exceptions, the caller method that can throw exception must include try-catch statements in the body or the throw clause in the header. For example, over here, we have caller A that has the try and catch block. So that is the catcher, while caller B, which is the propagator, it has the throws clause in its header. For example, for check exception, trying to read from a file. If I don't handle the exception, it will give me an error saying that unreported exception, file not found exception, it must be caught or declared to be thrown. So, two ways to do it. The first one is by using the try and catch, while the second one is by adding the throws clause in the header. So in the second one, we have public static void main throws IO exception. So those two are working just fine. Handling runtime exception. So this is an unchecked exception. So it is optional to include any try-catch block inside of it. Unchecked exception, it happens caused by the defect in the code that is being written. Summary. So in this topic, we have covered about exception handling. We have looked into try, catch, and finally blocks for catching and also handling exceptions. We have looked at catcher and propagator and how to propagate the exceptions. We have also looked into checked and also unchecked exceptions and how to deal with those kind of exceptions. On your online learning, I have posted activity 5 that has some MCQ questions on this topic. Try and answer those by today. I have also uploaded past year exam questions. Do those and submit it by 21st May. That's all. Thank you.